here in this video, we can discuss about the various uh, data integration. Okay, so here in data mining requires data integration. That means merging of data from multiple data sources. Okay. So here multiple data sources, and it can we need to avoid redundant data and the inconsistencies from that may occur from the various different types of data set, and we need to improve the accuracy and also the speed of the data mining process should also be increased. Okay, so here we can discuss some of the strategies that are used for data integration. Okay, so what is this data integration? That is, it combines data from multiple sources into a coherent data store, and it is stored in a data warehouse. So the main issues that should be considered while doing the integration processes, first one is the entity identification problem. That means if you are considering the real world entities from different or multiple data sources, the data analyst or the data entry people won't be knowing what the exact that particular field is referred to. Some people may enter the customer ID into customer ID, and some other people may enter the customer ID C_ID. Another people may enter that as customer number. So the from different sources, the same data we get different types, right? The header name would be different. So in order to avoid these confusions, we need to see the metadata of these databases. So the metadata plays an important role to help these data analysts to find out whether what is that particular field refers to, whether it is customer ID or it is a different another number, anything like that. So metadata will be having this type of information. Okay, so it may include actually what is this metadata? It will include the attributes name. It will be there, then the meaning of that particular field, data type, the range of values that are permitted to that particular attribute. So if or which all values that can be entered, null values, whether null values are permitted to enter that into that particular field or not. So here metadata can be used to help to avoid these errors in while doing this data integration. Okay, so again another problem is that while we do the data integration, redundancy may occur. That is, we can have the value. So here there will be, consider an example, there will be an attribute such as a annual revenue. Okay, so that will be redundant, and we can derive the same data from another set of attributes. That is, if we have a monthly income is there, then we can there is no need to again ask, or there is no need to have a field called annual revenue. So that or if you have a age or if you have a date of birth, then from that particular date of birth we can calculate the age of that particular customer, right? So these attributes can be removed. Okay, so that so by integrating these we have to see overcome these issues that are faced that are coming from different sources. Okay, so we can detect these redundancies with the help of a correlation analysis. Okay, so here in this correlation analysis, it is a measure that will say whether one attribute is dependent on another attribute, or whether the two attributes are totally different or totally independent. So in order to specify the relationship between the two attributes, we can have a correlation analysis. Okay, so if you are given two attributes and we need to measure that how much related is, if you are given two attributes, say X and Y, and we need to say that how much similar this X attribute to Y attribute. If you want to measure the similarities, then we can go for this correlation analysis. Okay, so here this it is done for numerical attributes, and we can have the correlation between any two attributes, that is A and B. Values should be numerical values. Okay. Then after computing this, we have to find out the correlation by using a correlation coefficient, and it is also known as Pearson's product, and it is also known as Pearson's product or a correlation coefficient. For example, when we see, we have a data set having three attributes, okay, and we have a person name, and we have two fields, that is male or is female. So the values inside this particular attribute is male and is female is that if the person is a male, then that is male will be 1, and the other value, that is a female value, will be a 0. And if the person is a female, then is female will be 1, the other value will be 0. So actually, there is no need to have these two values. Any one is required, right? If this person is male, if it is 1, then, or if it is 0, what does it mean? This particular row, this person is a female, right? So we can remove one attribute without any information loss. So here, as one attribute can easily say whether that particular person is a male or a female. So likewise, we can do the analysis correlation. With the help of the correlation analysis, we can avoid some of the attributes. Okay. So the main thing is that we have to use this particular thing in the numerical attributes. Correlation coefficient or calculations should be done over the numerical attributes. Okay. So here we see that how one attributes vary from other, or how much similar to that particular attribute to the other. Okay. So coming to this coefficient, that is correlation coefficient. So this is the equation that is used for finding the correlation coefficient. Okay. So here this is relation between A and B, and correlation coefficient, that is A and B. And this is some of this, N represents that it is capital N is the number of tuples that we are considering, and AIs and BIs are respective values of that particular attribute A and B. Okay, of the tuple I. Ith tuple in the A in the field and the value on AIM. Ith tuple in the B in the attribute in the value on a BI. Okay, so and again, anyway, we are doing this over the numerical values, right? So we need to find out the standard deviation of A and B and the mean values of A and B. So mean values will give you capital A and B, and A bar and B bar will be the standard deviation of A and B. And by using this equation, we can find out the relation between A and B. Okay, so here, this is how we will calculate the correlation coefficient. Okay, so here, and what does that mean? So when we get the value of correlation coefficient, that value will lie between -1 and to +1. This -1 is less than or equal to RAB, and it is again less than or equal to +1. Okay, so here this relation coefficient or correlation coefficient will be having the value between -1 to +1. And if it is less than 0, that means it is A and B are positively correlated. That means that is, if the value of A increases, then B also will increase. That is, it is positively correlated. When A is decreasing, then B also decreases. That is, the change of A and B are dependent. Okay, if any change occurs in A, that will affect the that may affect the value in B also. Okay, so here next, if the value is equal to 0, if RAB is equal to 0, that means that A and B are totally different one, or it is independent, and there is no correlation between them. Okay, and if the value is less than 0, means that it is A and B are negatively correlated. That is, if one increases, then the other one may decrease. Okay, that is a negative correlation. Okay, so this is about the correlation coefficient. Okay, so these are the different correlations. So in here we have the positive correlation. Then it represents a straight line that is moving from the left end to the right top end. Okay, and this is strong positive correlation again, and this is a weak positive correlation, and this is a no correlation, that is, it does not have any relationship between the two factors. Okay, two attributes. Okay. And again, this is a weak correlation. Again, strong. This is a perfect negative correlation. That is, one is increasing, the other might decrease. Okay. Then what does this mean actually mean? So we can see the meaning of this. If this value is 0.4, 0.4, that means it is a positive correlation, right? If the correlation coefficient of, if it is 1, that means that it is a positive correlation. That is, when a one value is increasing, it will, the other value will also proportionally, it may get increases. Okay, that is, if a shoe size goes up in utmost perfect correlation with the foot length, right? Again, the correlation is minus. Negative means that is a negative correlation. That is, if one is increasing, for example, the amount of a gas in the tank decreases in almost, it will correlation. It will be having a correlation with the speed. Okay, and zero means that does not have any relationship. That is, uh, every increase that there may not be having any positive or negative increase. They are just unrelated to each other. Okay. So again, there is another test that we can see. That is a correlation test that is called a chi-square test. Okay. Chi-square test, it is a correlation test for a nominal data or a discrete data. Okay, and if we have a discrete data, we can find out the correlation between two attributes, that is A and B, and we can see that it is discovered by this test, that is chi-square test. Suppose we have two attributes, that is A and B, and A has C distinct values and B has R distinct values. So A values are A1, A2, A3, etc. up to AC, and B will be having R distinct values, that is B1, B2, B3, etc. up to BR. Okay, and in order to find out the relationship, we can represent these data tuples in a contingency table. Okay, and we can see these values, how these are related. We will be having A and B can be shown as a contingency table with the C values of A making up a particular column and R values will make up a particular rows. Okay, and this can be computed with the help of a table. Okay, so this is the contingency table, and this will, the total value will be the total 450. After 450, male 250 male will read a fiction stories, at 200 male will read female will be reading a fiction stories. Non-fiction male will be reading non-fiction stories, and 1,000 female people are reading a non-fiction. So a total non-fiction is read by 1,050 members, and 450 members are reading a fiction. So something like that. Okay. So here, this is the contingency table of the given data, and we can find out the test. Okay. So here we need to find out the chi-squared value. So here the chi-squared value, we can take it by using this formula. Chi-square test is equal to, that is sigma I is equal to so chi-squared is I is equal to 1 to C. അപ്പം ആദ്യത്തെ ഫീൽഡ് C നമ്പേഴ്സ് ഉണ്ടായിരുന്നു, രണ്ടാമത്തെ ഫീൽഡ് D എന്ന് പറയുന്ന ആട്രിബ്യൂട്ട് 1 to R വരെ ഉണ്ടായിരുന്നു. Okay, അതുകൊണ്ടാണ് summation from 1 to R. And we have OIJ and EIJ. O means observed. O observed. Okay, observed value of IJ, and E means expected value. So what will be the expected value of that represents EIJ? Okay, so observed frequency, that is the actual count and of that particular joint event of AI and BJ, and EIJ represents the expected frequency of AIJ and BJ. Okay, so what is this EIJ? How we can find out the expected count? Okay, that is count of A, that is the attribute A, which is having the value AI into count of B, attribute B ആണ്, അതിൻ്റെ അകത്ത് BI എന്ന് പറയുന്ന BJ എന്ന് പറയുന്ന വാല്യൂ എത്രയാണ് വരുന്നത്, അത് നമ്മൾ മൾട്ടിപ്ലൈ ചെയ്യുക divided by the total number of tuples. So that by doing this, by applying this formula, we will get the expected number. Okay, so expected frequency നമുക്ക് കിട്ടും EIJ എന്ന് പറയുന്നത്. Okay, so ഇവിടെ n എന്ന് പറയുന്നത് സ്മോൾ ലെറ്റർ n sorry, and capital N means it is the number of data tuples, and this count of AIs, it is the number of tuples having the value AI for capital A, and count of B is equal to Bj is the number of tuples having the value Bj for capital B. This is an attribute. Capital A and B are the attributes, two different attributes for which we are finding out the relation by using the chi-square test. So this is the contingency table. Here we have numbers are there. So we need to find out the expected frequency of a particular cell, that is male having a fiction. Okay. So we are calculating this value, that is E11, that is count of male into count of fiction. So count of male and another, what is the count? Total count of male is 300. Left. Male into count is 300. Fiction or the total count of 450. So 300 into 450 divided by what is the total number of n and the total number of tuples are 1500. So that divided by 1500. So well, expected frequency and the 90 will. Okay. And again the chi-squared value kandupidikam. So chi-squared value means observed minus expected value. Okay. By observed value of male is 250. Fiction the observed value 250 that minus what is the expected value of male fiction 90. That's female in the fiction they formula apply female value 360. Non-fiction male 210. Non-fiction female 840. Detail that is 90 in the value. Similarly, we have to find out the fiction for female, observed expected value for non-fiction male and non-fiction female. Okay, so after finding out these values, we have to find out the chi-squared value. So by using the formula, that is sigma L, sigma of observed minus expected the whole square divided by EIJ, expected. Okay, the equation applies here. That is, what is this? Observed is 250 minus 90 and divided by the corresponding expected value, that is 90. 250 minus 90, the whole square divided by 90 plus summation. That is 50 minus 210. Observed is 50. So here is what non-fiction non-fiction observed is 50 and expected is 210. So observed minus expected divided by expected the whole square is here, the value to plus again observed is 200 minus expected divided by expected plus again 1000 minus 840 divided by 840. So we values calculate or value that is the chi-squared value. Okay, so here the p-value score can be determined by calculating the degree of freedom as well as the chi-squared value, and how we can find out the degree of freedom. So here the degree of freedom for this particular data set, contingency table data set in the degree of freedom the number of row count -1 and number of column count -1. So what is the row count? Row row non-fiction and fictional column count male and female. So 2 minus 1 into 2 minus 1, that is 1 into 1, that is 1. The degree of freedom is 1. So we can use this calculator in order to determine the p-value. So here in our cases, p-value will be less than 0.001, and the significant the result will be significant if the p-value is less than or less than 0.05. Okay, so here if since our computed value value p-value we can reject this hypothesis, and we can say that it is the gender preferring reading R. Gender preferring reading reading and independent and correlated correlation, and we can conclude that two attributes are strongly correlated for a given group of people. Okay, correlation undo illo ennu kanikkan vendiyana ഈ പറഞ്ഞിരിക്കുന്നത്. Okay. So another major issue when while doing the data transformation, the data integration is that it involves the detection and the resolution of data value conflicts. For example, if you're considering the same real world entity attribute, the values from the different sources may be different, right? So here the real world entities, the attributes value from different sources may differ, and this may cause some of the differences because of some of the representation schemes or scaling encoding schemes that are used by the different sources. Okay, for example, if you are while we are inputting a metric unit, okay, some people may be denoting their salary in rupees, some people may be denoting their in different standards. It may be in dollars or in PT, in euros. Some different representations are there for money, right? So everyone may not be having, may not be representing it in the same format. So we need to find out, and we need to do some of the process, data pre-processing steps, and need to take some of the actions. Okay. Again, then an attributes may also differ on the abstraction level. So where in an attribute in one system, it is recorded and may be recorded in the lower abstraction level. Okay, then the same abstract attribute in the another. Okay, so when and we can also see that an attribute in one system may be recorded at the lower level of abstraction than the same attribute in the another. നമ്മളതിനേക്കാൾ കുറച്ചുകൂടെ താഴ്ന്ന് ഞാൻ പറയാം, ഒരു ടോട്ടൽ സെയിൽസ് കൺസിഡർ ചെയ്യാന്ന് വിചാരിച്ചു. ഒരു ബ്രാഞ്ച്, ഒരു പർട്ടിക്കുലർ ഡാറ്റാബേസിന്റെ അകത്ത് ടോട്ടൽ സെയിൽസ് കണ്ടുപിടിക്കുന്ന ഒരു ഡാറ്റാബേസ് ആണെങ്കിൽ, ആൻഡ് വൈൽ ആ അട്രിബ്യൂട്ടിന്റെ അതേ തന്നെ ഡിഫറെന്റ് ഡാറ്റാബേസ് നോക്കുവാണെങ്കിൽ ദാറ്റ് വിൽ ഗിവ് ദ ടോട്ടൽ സെയിൽസ് ഓഫ് എ പർട്ടിക്കുലർ റീജിയൻ ആയിരിക്കും. അല്ലെങ്കിൽ ആ ഡാറ്റാബേസ് ടോട്ടൽ സെയിൽസ് അല്ലെങ്കിൽ ആ ഒരു പർട്ടിക്കുലർ സ്റ്റോറിലെ മാത്രം ഇതായിരിക്കും തരുന്നത്. ഒരു ഡാറ്റാബേസിനകത്ത് ടോട്ടൽ സെയിൽസ് തരുന്നത് ഒരു റീജിയൻ വൈസ് ആയിരിക്കും. വേറൊരു ടേബിൾ എടുക്കുവാണെങ്കിൽ അത് ആ ഒരു പർട്ടിക്കുലർ ഷോപ്പിലായിരിക്കാം. വേറൊരെണ്ണത്തെ സെയിം ഇത് കൊടുക്കുവാണെങ്കിൽ ഒരു കൺട്രിയുടെ ടോട്ടൽ സെയിൽസ് ആയിരിക്കും എനിക്ക് തരുന്നത്. ബട്ട് വി ആർ അപ്ലൈങ് ദ സെയിം ക്വറി അല്ലേ, സെയിം സാധനം കൊടുത്തു കഴിഞ്ഞാൽ വി വിൽ ഗെറ്റ് എ ഡിഫറെന്റ് റിസൾട്ട്. ഒരെണ്ണം ഏരിയ വൈസ് ആയിരിക്കാം, ഒരെണ്ണം കൺട്രി വൈസ് ആയിരിക്കാം, ഒരെണ്ണം ഷോപ്പ് വൈസ് ആയിരിക്കും. അങ്ങനെ ഡിഫറെന്റ് ആയിട്ട് നമ്മൾ ഡിഫറെന്റ് സോഴ്സിങ് ആയതുകൊണ്ട് തന്നെ അങ്ങനെ ഡിഫറെന്റ് കോൺഫ്ലിക്ട്സ് വരാനുള്ള ചാൻസസ് ഉണ്ട്. So these are the major issues that has to be considered while doing the data integration. So, okay, so that's about the data integration, and next step is step number 3. Okay, data transformation, that we can see in the next class. Thank you.